All right, in 5.2 part 2, we are going to pretty much just do a review from geometry. Okay, we're going to look at finding missing sides and angles of right triangles. So first, let's just go through solving for a missing side. The first thing that we want to do is label the sides. So what I mean by that is we want to label them with respect to the angle that we're given as opposite, adjacent, and hypotenuse. So for this angle here, we're given this 41-degree angle. The side opposite is going to be down here. If the x is going to be the opposite, and then this 30 is going to be the adjacent leg, and then this side will be the hypotenuse. All right. Then what we want to do is choose the appropriate trig function. Okay? The two sides that we're dealing with here are the opposite and the adjacent sides. So if I'm thinking in terms of SOHCAHTOA, adjacent and opposite, that's going to be tangent. So the trig function that I'm going to choose is tangent. The way that we set this up is tangent of the angle, so tangent of 41 degrees equals opposite over adjacent. So in this case, that would be x over 30. Then we just want to solve for x. In this case, all I would need to do is multiply both sides by 30, and that'll get x by itself. So we'll end up with 30 times the tangent of 41 degrees. And we can put that into the calculator, and in this case, the directions tell us to round to the nearest tenth. So one thing that we do have to make sure of is the mode on our calculator. Okay, this option right here, we can choose between radian and degree, and we will actually be flipping back and forth between these two a lot in this class. In this case, we're given angles in degrees, so we want to make sure that our calculator is in degree mode. Okay, so this is something you always want to check in trig, whether your calculator is in radian or degree mode. Okay, in this case, we want it in degree. So I'm just going to put in 30 times the tangent of 41 degrees. And that will get me that missing side, if I round this to the nearest tenth, is 26.1. Okay, then let's try another one. With respect to this angle, this would be the opposite side, this would be the adjacent side, this would be the hypotenuse. The two sides I'm dealing with are opposite and hypotenuse, so in SOHCAHTOA, that would mean I'm using sine. So my setup will be sine of 57 degrees, always the trig function of the angle, equals opposite over hypotenuse. So in this case, that would be 40 over x. So now, to solve for x, I actually have two steps. Right? First, I want to get x out of the denominator. So I'm going to multiply both sides by x. These x's cancel. And now, to get x by itself, I want to divide both sides by the sine of 57. So what we end up with then is that x equals 40 divided by the sine of 57. And that we can put into the calculator. And again, rounding to the nearest tenth, this would be 47.7. Okay, so now let's take a look at solving for a missing angle. It's pretty similar, okay, except we're going to have to use an inverse trig function here. We want to start out the exact same way. We want to label the sides with respect to the angle. So with respect to this angle that we want to solve for, this is the opposite side, This is the adjacent side, and this is the hypotenuse. So the two sides I'm dealing with are adjacent and hypotenuse. In SOHCAHTOA, that would be CA, so cosine is adjacent over hypotenuse. So I'm going to say cosine of the angle. They just use a question mark here. We talked about normally for an angle we use a Greek letter, so I'm going to go ahead and make that theta. So cosine of theta would equal adjacent over hypotenuse, so equals 48 over 52. So now we need to get theta by itself. We need to undo cosine. Well, the inverse of cosine is just inverse cosine. So I'm going to take the inverse cosine of both sides. Now, be careful what your perception is of this, right? This is not multiplying both sides by inverse cosine. This is taking the inverse cosine of both sides. Okay? It is an inverse operation, the same as adding and subtracting, the same as multiplying and dividing, the same as a log and an exponential. So the inverse cosine of cosine cancels out, and we're just left with theta over here equals the inverse cosine of 48 over 52. And that then we can put into the calculator. So to get inverse cosine, I'm just going to hit second cosine, and then 48 divided by 52. So the measure of that angle in degrees would be 22.6 if we round to the nearest tenth. So theta equals 22.6 degrees. Okay, we could easily change our calculator to radian mode and it would give me this same angle in radians. All right, let's do one more example here. Now in this one, we are actually given all three sides of the triangle. We can choose what trig function we want to use then, right? We're given the opposite side, we're given the adjacent side, and we're given the hypotenuse. So it doesn't matter what trig function I use. I just need to make sure I'm using the appropriate sides for the trig function I choose. Let's go with sine. I'll say sine of my unknown is equal to opposite over hypotenuse, so 36 over 60. And again, to get theta outside of that trig function, I'm going to need to take the inverse sine of both sides of the equation. So these cancel. We are just left with theta equals the inverse sine of 36 over 60. Put that in the calculator. So second sine, 36 over 60. And we get 36.9 degrees. So that missing angle would be, 36.9 degrees. One final example here. Right on this one, we need to solve for an intermediate length to find the one that we ultimately want. All right. Now, in the directions, it says round intermediate values to the nearest tenth. Usually I'm harping on taking intermediate values out to way more decimal places than you need. But in this case, it actually specifies round your intermediate values and then round your final answer as well. Okay, so let's go through one of these together. We actually need to solve for this. It's called an altitude right here. So what I'm going to look at is actually this right triangle here. Okay, and I want to solve for this side. We can call it y. So what I have here with respect to this angle that I know, this 25-degree angle, this is the opposite side. This would be the adjacent side, and this would be the hypotenuse. So if I want to solve for this side here, I'm dealing with opposite and adjacent, so that would be tangent. So I can say the tangent of that angle of 25 degrees equals 16 over y. Again, this would be a two-step process. Multiply both sides by y, and then divide both sides by the tangent of 25. I'm not going to write out all the work. I'm just going to go ahead and skip to writing this. And we can put that in the calculator. 16 divided by the tangent of 25. And we'll get 34.3. Now remember, the directions said round your intermediate steps. So 34.3 is what we would get here. So now I can kind of clean this up here and just replace this side, or label this side with what we know it to be now, 34.3. So now we can look at this right triangle. Okay. So with respect to this 36-degree angle, this is the opposite side, this is the hypotenuse, and this is the adjacent side. So now I'm dealing with the opposite and the hypotenuse, so I'm going to be using sine. So I'm going to have sine of 36 degrees equals 34.3 over x. Again, we would multiply both sides by x and then divide by the sine of 36. So we'll get 34.3 over the sine of 36. And let's put that into the calculator. 4.3 divided by sine of 36, and we'll get 58.4 if we round that to the nearest tenth. Okay, so 2 steps here in these last couple of problems. There are not a lot of good problems in the book for basic right triangle trig, so your homework is actually just going to be a worksheet, right, which I will work on in class. So that is it for this video. The final question is going to pop up asking you what questions you have.